Hi there, this is Penelope, and this is the third in the videos for topic 1. So this is topic 1 class 3, where we're looking at decimals. What we've got to make a difference between, or differentiate between, is the words place value and digit. The place value indicates the value of the place of a digit in a number, and a digit is just any of the digits that we talk about counting with 0, 1, 2, 3, 4, 5, 6, 7, 8 or 9. Now have a look at have a look at this number here, where it's 109,876,543,210.12345, and let's look at the names for the places for everyone that starts with a 2. So looking at this 2, we can see that it's in the hundreds place, so it means that we have 2 hundreds somewhere in our number. Have a look at the 3, this 3. That 3 is in the thousands column, so there are 3 thousands somewhere in our number. The 5, this one here, there are 500 thousands. As some examples, have a look at this one, 5, 7, 9. And let's have a look at the 9. In this one, the 9 is in the ones place, or sometimes it's referred to as in the units place. 9877. In this case, the 9 is in the thousands place. What about this big number, 8962, 212352. And let's look at the 1. And the 1 is in the 10,000s place. So if you look at the number system here, and then here, back to the decimal point, it's ones, tens, hundreds, thousands, 10,000s, and so on. It's going up in powers of 10, and from the decimal place onwards it's going down in powers of 10. Sometimes we need to approximate. It's not very practical to write numbers with very large numbers of digits after the decimal place. So we're going to approximate numbers. Sometimes we approximate numbers to significant figures. Sometimes we approximate them using decimal places. So for example, let's have a look at 9.4534. And if we want to write that to two significant places, two significant figures, we would look at the first 2, then we'd look at the third, and we'd see that the third was 5, which is greater than halfway, so we would round up, so we would make that 9.5. The next one, we're going to look for 3 significant figures, so we'd look at the first 3. Then we'd look at the next one, and the next one is 3, so it's less than halfway, so we would round down. For this one, these zeros, these ones, we don't really, well, they're important, but we don't count them in our significant figures, so we would be looking at these 2, and then we'd look at the third one. The third one is 5, it's greater than halfway, so we would round up, and we would rewrite that as being approximately equal to 0.0014. So approximately equal to, or that's another symbol for that, like that. 18.7249 to 4 significant figures. Let's count 1, 2, 3, 4. And let's look at the next one. The next one is 4. So we just leave it at 18.72. Now for the last one, we're going to look for 4. 1, 2, 3, 4. And the next one is rounded up. So we would write that as 8.127. We can also approximate by looking at the number of digits after the decimal place. So if we look at the first example there, we're going to do a 1 decimal place, so we go one digit after the decimal place, so that's 4. Look at the next one, it's less than halfway, so we would leave that as being approximately equal to 123.4. Then we're going to approximate it to 2 decimal places, so we would count 2 after the decimal place and then look at the next one. The next one is 6, so it's more than halfway, so we'd round up, so it would be 123.45. We're going to look for 3, so 1, 2, 3. That's the fourth one is over halfway, so we would round up. So we are just approximating, we're finding a number that's pretty close to what we've got, but just approximated a little bit. Now, a fraction is just an integer over another integer, and you can use long division or you use your calculator. We've got an example here of 1.224. What we need to do is we'll write down the whole thing as just the decimal part of it anyway. We'll write that down as a decimal over 1. Now we're going to multiply top and bottom, so it's written like that. So now we're going to multiply top and bottom by 10 for every number after the decimal point. So we're going to multiply it by, for every 10 after the decimal point, so that means we're going to multiply it by 1, 2, 3, because there are 1, 2, 3 numbers after the decimal point. So that our 0.224 would be 224 over 1,000. And then we'd have to add on the 1, which would be 1,000 over 1,000, which then would give us 1,224 over 1,000. And then we could divide it by various numbers to simplify it, in which case we would end up with 153 over 125. If we're looking at 0.52, so we've got 0.52 over 1, and we're going to multiply by 10, we've got on the bottom, we're going to multiply it by 10 times 10, because there are 2 numbers after the decimal place, and we're going to multiply the same on the top, which gives us 52 over 100, and we can simplify that. We can divide that top and bottom by 4, and we get our answer like that. There are various things we can do with the calculator. If we have 7 over 4, for example, if we hit Shift and then the S arrow D button, then it will write it as 1 3/4. It's all very clever. So we can do these on our calculator. Some of the numbers that we look at as fractions aren't accurate, and if you do them on your calculator, if you do 1 divided by 3 on your calculator, which is what that says, then you're going to get a number that looks like that, and it will go on being 3 no matter how many places your calculator has. So if we want to approximate that, what we would say is it's equal to 0.3, and to tell us that the 3 is repeating, we'd put a dot over the 3, and we'd read it as 0.3 recurring. If we have 1 over 7, if you look that up on your calculator, that's 0.142857, 142857, 142,857. You can see what's happening. the 142857 is repeating, so we would put a dot over the 1 and a dot over the 7, because then that tells you that the whole pattern is repeating. 2 over 11 on your calculator is 181818 ... and so we could write that as 0.18 recurring. Now we want the 18 to recur, so put a dot over the 1 and a dot over the 8.